Okay, we are gonna continue with the MMF distribution. Uh, Here we have more coils. It is telling us also to verify with MATLAB. Okay, so just like in the last video, we are gonna follow the convention that when the flux is entering the rotor, we are gonna say that the MMF is positive, and when it is going out of the rotor, we're gonna say that the MMF is negative. So I'm just gonna name each of these coils. This one is gonna be A. Now the other side of the coil, the one that is going into the page, is gonna be A dash. I'm gonna call this 2A, 2A dash, 3A, 3A dash, and this is gonna be 2B. I'm gonna call this 2B dash, 3B, and 3B dash. Okay, so I'm gonna start with coil A. So here we can see that this is 0 degrees. The coil is at 90 degrees. So from 0 to 90, we can see that the flux is going out of the coil. So we are gonna say that the MMF is negative. And in terms of the magnitude, this is that is 5 amps. We have 10 turns. So we have 10 turns times 5 amps. And we know that the MMF in the air gap, the side of the air gap, is half. So here we have 25 for coil A. So 25 minus 25, so from 0 to 90, we're gonna have minus 25. And now we see that from 90 degrees to 270, the flux is going into the rotor. So we are gonna say that the MMF is positive. Okay. And then from 270 to 360, we follow again that it is going out of the rotor. So we are gonna say that it is negative. Okay. And now we are gonna go with 2A. If you notice, 2A is just 30 degrees behind coil A. So we are gonna have something similar here, but this time the flux is going out from 0 to 60. So it's negative from 0 to 60. And in terms of the magnitude, it is A times 5 over 2. So we are gonna have 20. So here we're gonna have 20, here we're gonna have minus 20. So we are gonna have negative until 30 degrees below this one. We're gonna have positive until 30 degrees behind 270. If you notice here, this is 270, so 30 degrees behind. Similarly for coil 3, this is gonna be 30 degrees behind this one, so it's gonna be negative, and the magnitude is 5, so 5 times 5 over 2, that's gonna give us 12.5 and minus 12.5 MMF. So we know that this is negative up to here, then it goes positive. Now we knew that is 30 degrees behind this curve, so it's gonna be 30 degrees behind. Okay, so it is always 180 degrees positive and 180 negative. And we can do the same analogy for coils 2B and 3B. We know that they are ahead 30 degrees from 90. So for this one, it's going to be negative, and we know that these two have the same magnitude, minus 20 and 20, because 2A and 2B have the same number of terms. So we know that this one is going to be negative until 30 degrees plus 90, and it's going to be positive until 30 degrees after 270. And for the next one, we know that this is 12.5 and 12.5. We know that this is going to be negative 60 degrees past 90, and it's going to be positive 60 degrees past 270. Just to make sure that the point is clear, here we have 90 plus 30 plus another 30. So we know that, okay, here we have our coil, sorry. So we know that this is for 0 degrees. So we know that the flux is going this way. So from 0 to 180 minus 30, minus 30, 150. From 0 to 150, the flux is going out of the rotor, so we are going to say that is negative. And that's what we have here. And then it is positive 180 degrees, and then it's negative again. So it's the same MMF, just that it shifts 30 degrees depending of where we place the coils. And now we need to calculate the total MMF. So the total MMF is just gonna be the sum of all these coils. So we see here we have minus 25, minus 20, minus 12.5, minus 20, minus 12.5, from 0 to 30 degrees. So from 0 to 30 degrees, we have the sum of all the negative, and that's giving us minus 90. So from 0 to 30 degrees. Now, from 30 to 60 degrees, we have minus 25, minus 25, plus 12.5, minus 20, minus 12.5. And that's going to give us minus 65. So that's for 30 to 60. Now, from 60 to 90, we have minus 25, plus 20, plus 12.5, minus 20, minus 12.5. That's going to give us minus 25. Now, from 90 to 120, we have plus 25, plus 25, plus 20, I'm sorry, plus 12.5, minus 20, minus 12.5. And that's going to give us plus 25. From 90 to 120. I can already guess that this is gonna be 65 and this is gonna be 90. But let's see. From 120 to 150, so we have 120 to 150 is gonna be plus 25 plus 20 plus 12.5 plus 20 minus 12.5. So we got 65. Now for 120, 150 to 180, wait a minute. Okay, from 150 to 180, so we have 25, 20, 12.5, 20, and 12.5. So this is gonna give us 90. Okay, and now from 180 to 210, 180 to 210, so 25, 20, 12.5, 12, 20, and 12.5. So we still got 90 here. And now from 210 to 240, so we got 25, 20 minus 12.5, 20, and 12.5. So that's gonna be 65. Okay, so we know that it is just gonna follow the same because they are a mirror. So it's gonna follow. If you want, you can just do the rest, but we know that it's gonna be the same for the other side. And now it is asking us to check this with MATLAB. So here I have a MATLAB script. Hope I really hope you can see. So first I just have a vector of angles. Here we can see it. That's just going from 0 to 360. That's gonna be our x-axis. Now I do the calculations for each one of the columns. The angle for A is 90 degrees. We have the magnitude of MMF. That's gonna be the number of turns times the amps over 2, and the MMF that is calculated with this function that is just creating a vector of ones. I call this middle, so this is gonna be the middle part of the of the signal of the MMF, because I can see that we got three parts always. We got the start, the middle, and the end. So, and we know that this middle is always 180 degrees. So that's what I'm doing here, creating the middle part, and I'm multiplying it by the magnitude of the MMF. Now, if A is 0, then it just has two parts, the middle and the middle minus 1. So, because if the angle started at 0 here, let's say the dot is here and the cross is here, then this will be 0 degrees and 180, and we will know that from 0 to 180 the flux lines go into the rotor, so it will be from 0 to 180 it will be positive, and then it will be negative, so it will only have two parts. Okay, now if it doesn't have Uh, if it is greater than 0, then I have an initial part that is just gonna be all the ones, a vector of ones, uh, plus 1 because this one is not counting from 0, and I multiply it by times minus the magnitude, because as we can see in every example, the MMS from 0 to the angle at which the coil is in is always negative. So for the initial part is always negative, so that's why I multiply for minus the magnitude. And then for the last part is the rest, so that will be 360 minus whatever the place of the angle was of the coil, minus 180, and I multiply it by the magnitude of the MMF. And I do it negative because, again, we can see that in all of the examples, the last part was negative, because it is always 180 degrees positive and then 180 degrees negative. Okay, then that's how we are calculating the MMF distribution in space over the air gap. And now we do the same for each coil. So we have one at 90, one at 60, one at 30, one at 120, one at 150. And the total MMF is just the sum of all these coils. And now I'm just plotting the total MMF. Now I'm going to run it, and we can see here that we get something similar to what we calculated. So we can just put some points to make sure. So we said that from 0 to 30 we will have minus 90. Okay, we said that from 150 to 180. Okay, 150 to 180 is gonna be 90. I kind of, okay, here 150 to, well, 180 will be around here. It's gonna be 90. Okay, we know that it's negative for this size. Okay, so I hope this helps. That's it.